I'm Mr. Franklin, and this is a overview of the Math 2 chapter on statistics called the Regression and Correlation chapter. At the beginning of the chapter, you are given some learning targets, but these can be hard to understand what they are asking for because you don't know what all these vocab words mean, so I'm going to give you a quick overview. In real life, you might be given just a set of data. Here is a set of data in the form of a table. This is information from 25 countries on carbon dioxide emissions and the life expectancy at birth. And you can get some information from this table, like the carbon dioxide emissions in metric tons per person for Italy was 2.2, and the life expectancy was 79.5 years for a person born that year. But that's not very meaningful compared to all of the other numbers, so we're going to learn to visualize the data. You probably already know how to make a scatter plot. Here's a nice graph with our title and our labels on the axes and the scale. You can see what the numbers are so that you can easily read a point off of this table, off of this graph, and match it up with something on the table. You might look at the coordinates of this point right here and estimate that is 5.2 on the emissions axis, but 80 on the life expectancy axis. And we can see some of the points don't fit the rest of the pattern of the data very well, like this point down here that has coordinates 2.5, 44. What's going on with that point? Well, let's go look at the table, and we can see by looking down here, South Africa has those coordinates. So we might think, what's going on in South Africa? And we might even think, should we even be including South Africa in the rest of these data points because it's an outlier? We are going to learn to start analyzing this data using some numbers that we call statistics. So one of the statistics is R, the strength of the correlation. Correlation is the relationship between the numbers. And we can see that if we draw a nice oval around all of the points, we get kind of a fat oval. And I would estimate that the strength of this correlation is only 0.3. But then I think about South Africa, and I think, is there something else going on in South Africa that makes it different somehow from the other countries? Doing a little research, I might find that, yeah, that's true. I won't go into that now. You can do your own research. I might decide to leave South Africa out of my data set. And I can see that when I take that out, the strength of the correlation, by drawing an oval around here, I can estimate that to be much higher. Now it's a strong correlation, a relationship between these two variables, carbon dioxide emissions and life expectancy. And I can see that since this oval is pointed generally up when I go from left to right, that is a positive number, meaning that as carbon dioxide emissions increase, I can generally expect life expectancy to increase. Generally, but not always. Remember, South Africa down here, it's not true for South Africa. But the general trend is what we're looking for. And we can analyze that trend even further with what we call a best fit line, or more specifically, the least squares regression line. But I just call it the best fit line. This line, we can see, has a positive slope, and it cuts right through the middle of the oval, through the line through the data points. And we can get some information about that line. For example, if we pick 2 points on the line, like 5.5, 80 right here, and 1.5, 70, notice that that's actually one of the data points, then we can calculate slope. And we can calculate the y-intercept. or maybe just look at that right on the graph. This is an estimate after all. And we can come up with a equation for that line of best fit, and then we can use that equation to make some calculations. Something that occurs to me is that I've heard that carbon dioxide is bad for us. That's the greenhouse gas. And this graph seems to be telling me that as carbon dioxide increases, then life expectancy increases, which is kind of backwards from what I would think if carbon dioxide is really bad for us. So in this case, I might have to start asking some questions about why is that not what I expect. In other words, there's a correlation between these two variables, but it doesn't seem to be one causing the other. And I might realize that as there's more industry and a better economy in countries, not only does their carbon dioxide emissions go up from all that industry and like driving cars and producing electricity, but also things like healthcare gets better, nutrition gets better. These are things that would add to life expectancy. So, by analyzing a graph this way, we can find some unexpected trends and start asking the right questions. And that's what analysis of statistics is really all about. In these problems here, I've looked at estimates, things I've done by hand, and calculations I've made by estimating. We're also going to use some online tools like Desmos to be much more accurate and, in a lot of cases, make things easier, so that we're going to be able to calculate the correlation coefficient and the line of best fit using online tools that hopefully will make life a little easier, but also give us more accurate numbers. And that's what we do when we are given an unsorted pile of data so that we can analyze the relationships between them. Thank you very much, and have a great day.